Welcome back to Further Solutions Academy. On this video, I'll be working on the second example of Frobenius. Sorry, I'm talking about Frobenius. Sorry, Frobenius method. Frobenius method. Okay, that is what I'm talking about. By the end of this video, I think you understand better. I've done the introduction part and the condition of using it in the first video. Now, I have this particular problem, solution to Frobenius. Let's see how it is. Now, I think as it is, it has a regular singular point, which is my regular singular point. It will be equals to what? S equals to 0. Please take note of that. That is my regular singular point. My S equals to 0. Now, since I want to use Frobenius method, my y will be equals to sum of n run to infinity to infinity a of n s of n plus c. Take note of that. Very, very important. Now I will now move on by having my y prime equals to what? It runs from what? N to 0 to infinity. I have n plus c. I have a of n plus c. Now, since I have this, I can now say that my y prime will be run also to infinity. I have n plus c. I have n plus c. This is going to be minus 1, and a of s n plus c minus 2. Now, that is my what I need to do. Now, I think I need to be very fast because of time. Plus 2, 3xy, y prime plus bracket of 1, 2, x bracket of y equals to 0. Now, put those things there, this, and this, in the given equation, which I'll be having x squared bracket of sum of n to 0 to infinity, and I have n plus c. I have n plus c minus 1. I have my a of n plus c minus 1, and plus the next one, I have 3x into bracket of sum run from 0 to infinity. Also, I have what? N plus c, and a of n x n plus c minus 1. It's good to close the brackets. It's good to close that. Plus the last part of it, which I will be having a of n, plus we have 1 plus 2x, and bracket of what's my y? My y is given as sum run from to infinity. I have a n s n plus c. I think there's no any problem. No problem. Now, since I have that, now at this point, take note of this. If I do this, it will be plus 1. It will be plus 1. Yes. The first one will be 4 plus 1. Now, which I will be, I think, with that, this is going to be what? Sorry, this is going to be 2. Sorry for that. I made a mistake. Wow. Now, since I have that, I cannot continue. My marker is getting filled. Okay. I cannot continue by having the next thing I need to do. Oh, there's no any mistake. No. Now, if for you to see very well, how I wish you can see it, but for better understanding, let me not rush. I have n to 0 to infinity. Now, this one and this one, the s here will cancel this. It means I'll be having a of n n plus c minus 1, and I'll be having x raised to power n plus c. Yes. Okay. And plus this one will be having I'll be having 3 sum of what? 3 run from 0 to infinity. I'll be having 3, which is going to be what? 1. I have n plus c, and a of n, and s n plus c. Yes, that s will counter it. Yes, we counter this one, and the The next one will be plus. Now I'll be having summa of n to infinity run, and I'll be having a of n and s raised to power n plus c, and minus 2, which is summa run from 0 to infinity, is a constant. 2 can be inside, which I'll be having what's a of n Sn plus c plus 1 equals to 0. Yes. Now I think I've expanded the whole stuff now. These they're having the same counter. They're having the same counter. Since I have that, I can answer that what a summa of this would be brackets close open, covered everything. I have n plus c. I have n plus c minus 1. I have 3 bracket of n plus c, and I have plus 1 close bracket a of n Sn plus c, and minus, and this will now be equals to summa. Now summa of n to 0 infinity, I have a of n xn plus c minus, which is equals to 0. Now the only thing we can do now is that we can move this, we can shift this, but we cannot shift this. Yes, we can shift that. We can now we cannot shift the other one. Okay. Now for us to shift that, we just say that what in this here equation, put n equals to 0 in the first summand. Now my first summand, which is the lowest power, that is my first summand is this. This is my first summand. It means when I have my n, it will shift by 1. I will shift it by what? By 1, by saying that anywhere I see n, it means I'll be having a naught plus bracket of a plus c, n plus c minus 1 plus 3 bracket of 0 plus c plus 1 s c plus 0 plus. Now since I have this it will be it will now be what? Summa run from n to 0 to infinity. It will be normally this and this are like times, which I'll have to, if you have got that, which are to avoid space, a of n bracket of n plus c squared plus 2 bracket of n plus c plus 1. There is plus 1 here. I think I'm closing the brackets here. Let me put my plus 1 here. Let me just put plus 1. I'm closing the bracket plus 1. I'm closing the bracket of Sn plus c. Okay. Minus 2 summa of n to, this is going to be 0, and a of n Sn plus c minus 1, plus 1 equals to 0. Now, that is what we need to do on that. That is what we need to do on that. Now, with what I'm having here, I have CCN, I have now it will be 3C, and all what I'm going to be having there, it will be what? It will be C, A of N, A of naught. I will be having C squared plus 2C plus 1 of XC plus, now here will now be what? Don't forget that this has been moved. Oh, sorry, I didn't even indicate. It has shifted by 1. I've shifted that one by 1. It will be summa of n to 1 to infinity, which I have a of n. I factor that n plus c bracket of squared, n plus c bracket of squared, and and plus 2 bracket of n plus c plus 1 brackets Sn plus c minus 2 summa of n2 is 0, infinity, and a of a naught Sn. Now Sn, if I am to shift this because of space, what can I do now to make that to be 1? I think I can say that okay, I can say that to make that to be 1, okay, I think I'm having c plus minus plus 1, don't let me stress myself, equals to 0. Permit me to put that. Now, since I have this, what can I do? It means I can generate my initial equation. This is my initial equation. My initial equation will be equals to c squared plus 2c plus 1 equals 0, which implies c plus c plus c plus 1 equals 0. It means my c will be 1 twice. It's repeated. My c will be repeatedly. Now, I think I can now shift this one. If I'm to shift that one, I think I'll be having the counter will now be n to 1, infinity, and I'll be having a of n c plus 1 bracket of c squared plus n plus c, and minus 2 bracket of n to 1 to c. It means I'm just saying that my n will be equals to what? Minus 1. What I'm trying to do in the second summand, this summand, it means my n will be equals to n minus 1. That's what I'm doing there in order to shift it. Now, it means if that is the case, I'll be having a of n minus 1 Sn plus c. 1 will nullify that one. That is equals to 0. Now, since I have this, I think I can now continue. What else can I do? Now, I think I'm making sense now. They are having the same counter. It means I can now say of n to infinity. To avoid that, I don't need to stress myself. Okay, for better understanding, to infinity, and I'll be having c plus 1 of a of n. This is going to be squared, and minus 2 a of n minus 1, and close the bracket like this of x c plus c equals to 0. Yes, permit me to rub this part because of space. You can see now that it's nice to study mathematics. Which you are doing it inside exam, you see how nice it is. Now, it's a nice part of mathematics that once you know it, you'll be very happy with yourself. Don't forget that c is equals to what? C equals to 1 twice. Now, I can now generate my recurrent. Now, to get recurrent equation, which is I'll be having n plus c plus 1 squared of a of n minus 2 a of n minus 1 equals 0. N will be greater than equals to 1. Please take, because the counter starts from what? 1. This is going to be I'm not making this is n. I made a mistake, sorry. Okay, it started counting from what? From 1. Now, from 1, counting from 1 and above. Now, since I know that, it means I will say that my a of n will be equals to 2a of n minus 1 divided by n plus c plus 1 all squared. Yes, that is what I'm going to be. Now, don't forget that when my c equals to 1, don't forget from here, my c equals to 1 from somewhere here. Okay, my c equals to 1 from there. It implies that my 2, it means my a of n will be equals to 2a of n minus 1 divided by, I have 1, I have n plus 2 all squared. That is what I'm going to be doing. Now, I can now say that what? When n equals to 1, I can't start counting from 0. Don't forget that my n is greater than or equals to what? 1. When my n equals to 1, it means my a1 will be equals to 2 of a naught divided by 1. That is going to be what? 1, 1, 1. That will be what? 3 square. Yes, that is going to be. Hope I'm not making mistake. Okay. I'm not making mistake. There is something wrong somewhere. This is supposed to be minus. I don't know. There is mistake somewhere. If that can be give us minus. Okay. There is mistake somewhere. I'm trying to figure out the mistake. Oh, sorry. My c is equals to minus 1 twice. Sorry. Okay, sorry for that. But I was thinking of there is a mistake somewhere. C will be equals to minus 1 twice. If that is the case, it means this will be equals to, because I was looking at this solution, is not giving me what I want, minus 1, which may be what I will be having squared. If my c equals to minus 1, my c equals to minus 1. Okay, c equals to minus 1. Right? Now, since I have that, my n equals to 1, it will be 1 squared. My n equals to 2 will be what? A2 equals to what? 2a1 divided by what? That will be 2 squared. Now, a equals to 3. I mean, n equals to 3. It means my a3 will be equals to 2a2 divided by what? 3 squared. That is how it will be moving. That is how it will be moving and be moving, which is going to be 3 squared. 3 squared. Okay. Now, implication, it means by implication, this one will be my a naught, which I'll be having a naught, 2a naught. By implication, this one will be what? 2.2 a naught all over what? All over 2 squared, which is equals to what? A naught. Now, sorry, a naught. And by implication, this one will be equals to 2.2.2 divided by what? 1 squared, 2 squared, 3 squared, dot a naught. That is what we are to be working towards. Now, it means my n of n will be equals to 2 of n minus 1 divided by what? N squared, which also implies 2 of n a naught divided by what? N factorial bracket of what? Squared. Now, it means my y, it will be y1, it will be equals to summa of n to 0 to infinity and a of n Sn plus c, which I'll be having, you can now put those things, which implies I'll be having implies Yes, hope I'm not making a mistake. No. Now it will be summation of n to 0 to infinity, and it will be what? 2n a naught divided by n factorial bracket of squared of Sn plus c, which also can be implied. Sorry, I have to use implies what? My a naught, which is going to be a naught, is going out of the bracket of limitation of sequence. I mean summation with 2 of n bracket divided by n factorial bracket of Sn plus c. Now, with what I've done now, sorry, permit me to manage this part of the board. With what I've done now, I think I can now say that what my let me assume that my a naught equals to 1. My a naught will be equals to 1. It means I'll be having y naught, y1 equals to what? Summation of n equals to this, to infinity, 2 raised by n divided by n1 square. This is a factorial of x n minus 1. Because minus 1, it means it will be minus 1 because my c equals to minus 1. My c equals to minus 1 from here, from the statement. Now, which I'll be having my y1, it will be equals to s inverse plus summation of what? To 1 of infinity, 2 of n, and s raised to power n minus 1 divided by n factorial squared. This is a counter. Now, that's what we are talking about. I think we have to stop here. Don't forget you are home with further solutions academy. Help us to share our videos, subscribe if you have not subscribed before. Once again, thanks for watching.